Trigonometric Equations. In this exciting video, we shall solve the following equations, sometimes in degrees and sometimes in radians, including sometimes in terms of pi. We've got 5 cos x equals 2, sin x plus 27 is 0.12, tan 2x is minus 1, 4 sin x is 9 cos x, 1 plus cos x is 2 sin squared x, and finally, sine of 74 minus x is minus 0.2. So, number 1, 5 cos x equals 2, and we're looking between 0 and 360 degrees. First of all, we've got to divide it by 5, so that gives us cos x equals 2/5, and since cos is positive, we'll be looking at the A and the C regions. The inverse cos of 2/5 is 66 degrees to the nearest whole number, so we'll be labelling 66 degrees in the A region to the x-axis, and the same in the C region, where cos is positive. Always starting anti-clockwise from 0, we go round, and obviously the first answer is just 66 degrees, but the second answer is 360 minus 66, or 294 degrees. Number 2, sine of x plus 27 is 0.12. Again in degrees between 0 and 360. Well, sine is positive, so we're going to draw lines in the A and S regions. The inverse sine of 0.12 is 7 degrees to the nearest whole number, so we have an angle of 7. But if x plus 27 is 7, that means that x is minus 20, which is out of the range 0 to 360, so we can't use that one. Carrying on, anti-clockwise, we get to 173, 180 minus 7. If x plus 27 is 173, that gives us x as 146, which is in our range. There are 2 answers, so we do need to carry on. And another revolution round back to the A region takes us to 367. And if x plus 27 is 367, then x is 340. And again, that's in the range we require. Number 3, tan 2x is minus 1. This term we're looking at radians, 0 to 2 pi, and giving our answers in terms of pi. Tan is negative, so we're going to be looking at the S and C regions, because t is positive in T and A, and we're looking at the negative. The inverse tan of positive 1 is pi over 4, which means that we have angles of pi over 4 in the S and C regions to the x-axis. So for the first angle, 2x is going to be pi minus pi over 4, which is 3/4 of pi. And the other angle will be 2x is 2 pi minus pi over 4, which is 7 pi over 4. There are, however, 4 solutions for this equation, because it's a 2x, so we need to go round again for both of those. And 2 more revolutions give us 11 pi over 4 and 15 pi over 4. All we need to do to finish off is to actually divide those by 2, because we want to know the value of x. So x will be 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. Number 4, 4 sin x equals 9 cos x, this time between 0 and 2 pi, not in terms of pi though, just in normal radians to decimals. Now this equation has 2 variables, it has a sin x and a cos x, so we can't just solve it straight away. What we need to do is use this formula, tan x equals sin x over cos x. So when we divide both sides of the equation by cos x, and also by the 4, we get tan x equals 9 over 4, and the inverse tan of that is 1.15 radians. 9 over 4 is a positive number, so we're looking in the A and T regions. We put our 1.15 radians to the x-axis in those regions. The first answer is just 1.15 radians, but for the second answer, we need to add on pi, and that gives us 4.29 radians. Number 5, 1 plus cos x equals 2 sin squared x. This one's in radians as well, in terms of pi. Again, we have 2 variables in our equation, but we can't use the tan x equals sin x over cos x formula, because we've got this squared. So what we do instead is we use sin squared x plus cos squared x is 1. And we eliminate the sin squared x, rewriting it as 1 minus cos squared x. So we substitute in, we multiply it out, we rearrange it to make it a quadratic equation. 2 cos squared x plus cos x minus 1 is 0. And then we factorise that, and the answers are cos x equals a half, or minus 1. Considering the half first, cos is positive, so we have our A and C regions. The inverse cos of a half is pi over 3, in terms of pi. And the second answer will be going all the way around. 2 pi minus pi over 3 will be 5 pi over 3. When cos x is minus 1, the cast diagram doesn't really help that much. But if you consider the graph, cos x is minus 1 at 180 degrees, or in radians, pi. Finally, number 6, sine of 74 minus x equals minus 0.2, back to degrees 0 to 360. Sine is a negative number this time, so we'll be looking at the t and the c regions, and the inverse sine of 0.2, positive 0.2, is 12 degrees. So, from the diagram, the angles are 180 plus 12, 192, and 360 minus 12, 348. However, 74 minus x equals 192 gives us an x value of minus 118 degrees, which is out of range, and 348 would be even worse. So instead, we have to go the other way. We go clockwise instead of anti-clockwise. So clockwise from 0, we come to minus 12 degrees first in the C region, and if 74 minus x is minus 12, then x is 86, which is in our range. Continuing further clockwise, we come to minus 168. If 74 minus x is minus 168, then x is 242, and again, that's in our range. Here concludes our discussion of trigonometric equations.